All right, kids. This is the Walking Dead test. First version. Don't know of the specific name, but I'm looking it up. I think version I is the version. Okay. So what I'm going to do is just crank this out real quick. All right, make sure the papers are properly placed. Okay. 50 kilogram zombie. I'm going to have to make a simple pendulum with him in a 9-second period. Simple pendulums, T is 2 pi square root L over G. This is mass independent, simple pendulums. So I'm looking only for the length of this. T squared 4 pi squared L over G. Solve for L. L is G period squared over 4 pi squared. G is 10, 213 equivalent for gravity. T is 9, 4 pi squared. 10 times 81 divided by 4 times pi squared. 20.5 meters. So the zombie will have to be on a simple pendulum, or that is 20.5 meters long. Spring pendulum, frequency of 16 hertz. Period, 2 pi, M over K. Now, the only unknown in this is K, spring constant, so we're going to be looking for that. T squared, 4 pi squared, M over K. Solve for K, K, 4 pi squared, M over T squared. 4 pi squared, 50. T. Now, I asked for T and I gave you F. So this is basically 1 over 16 squared. So 4 pi squared 50 times 16 squared. Now it's going to be really big. 5.05 times 10 to the 5th newtons per meter. So, hey, it's a number. Deal with it. All right, number 1, fluids. Glenn going down 20-meter hill. This is going to be a combination of equation of continuity. A1 V1 equals A2 V2. Pi, they are circular. Pi R1 squared V1 equals pi R2 squared V2. Pi's cancel. I'm looking for V2. That's one of the missing variables. R1 squared over R2 squared, V1 is equal to V2. Now, I don't have to use meters because centimeters squared over centimeters squared is just cancels to be a number, so it's not affected, doesn't affect anything, times 2. 144 times 2 divided by 25. 11.52 meters per second. Okay, next part. I want to know the pressure at the bottom. Got to use P1 plus rho G H1 plus 1/2 rho V1 squared P2 plus rho G H2 plus 1/2 rho V2 squared. I'm looking for P2. H2 is at the bottom, that's 0. So this is P1 plus rho G H1 plus 1/2 rho V1 squared minus 1/2 rho V2 squared. Now granted, this is sewage, but we are treating it as water, so rho is going to be 1,000. The other thing that we have to be is consistent with our units. I want the answer in atmospheres. These are going to produce results in newtons per meter squared, so it's P1 plus rho g H1 plus 1/2 rho V1 squared minus 1/2 rho V2 squared divided by 1.013 times 10 to the 5th newtons per meter squared per atmospheres. That's in atmospheres. This will produce atmospheres, and that will be P2. So to calculate everything, P1, 1,000, 10, 20, 1/2, 1,000, V1, V1 2 squared minus 1/2, 1,000, V2 squared, 11.52 squared. Part of me may remember that the numbers may be slightly off, but to let you guys know, I've done the numbers for the test tomorrow and they work out great. And so this is P2. This may end up being negative, but let's find out. 1,000 times 10 times 20 plus 500 times 4 minus 500 times 11.52 squared. Yay, positive, divided by 1.013, 10 to the 5th, 2.34 atmospheres. And that's the pressure. How many cubic meters of water pass through the pipe in 30 seconds? Volume is flow times time. The flow is the area times the velocity. So this is, we can use pi r1 squared v1. You could also use pi r2 squared v2 times time. So pi r1 0.12 squared v1 2 time 30. Units have already been changed into meters, so this should give an answer that is in cubic meters. .71. And just for people who are watching, I don't care about sig figs. We're more interested in the physics. All right, that's problem 1. So the answer 2.71 meters, pressure 2.34, final velocity 11.52 meters per second. Atwood string, the famous bucket of brains problem. So for something like this, it is a string, so frequency is NV over 2L. L is the vibrating portion, so L is equal to L1. V is equal to tension over linear mass density. So this becomes N over 2 L1 square root T over lambda. Now tension, because the sum of the forces on Y is equal to 0, this is equal to T minus the mass of the bucket of brains times gravity. So T is mass of the bucket of brains times gravity. Lambda is the mass of the string divided by the total length, which is L1 plus L2. So put these in. The frequency is N over 2L1. Tension, mass of the bucket of brains times gravity times L1 plus L2 divided by the mass of the string. Now, one of the things that I love to do is substitution. The mass of the bucket and the bucket is massless. Bucket has no mass. Looking for the number of brains in the bucket. So the mass of the bucket of brains is equal to the number times a single one of the brains. Bad choice in letters, but I'll just write M sub BR for mass of brain. The other thing is I know that mass of a brain is 1,000 times the mass of the string. So F is equal to N 2L1, mass of the bucket, N MBR, gravity L1 plus L2, divided by MS. Substitution, N over 2L1. Never asked for the specific mass of the brain. N MBR becomes 1,000 MS. G L1 plus L2 MS. MS is canceled. Now everything is known except for the one unknown, the actual number of brains. That's what's being asked for. First thing, squared. N squared. 4L1 squared. N 1,000 G L1 plus L2 divided by 1, because there's nothing else in there. I'm looking for N. That comes up 4L1 squared F squared divided by N squared 1,000 G L1 plus L2. That is N. 4, 3. I needed the frequency. Frequency of this thing. Oh, I know what we have to do for this. Hey, what's up?
You recording?
I am recording.
Okay. Try and work number 2.
I'm almost done with number 2.
Okay.
Want to watch?
Yeah.
All right. This is the wavelength is actually 1.5 meters. The N, this is 1, 2, 3, 4. So we're dealing with a fourth harmonic. Oh, I think I know what I did back then. Let's see. V is lambda F. Because the one thing that I do need the frequency. Maybe I can substitute that out. Oh, I think I know what I did. V squared over lambda squared. So I may have to back this up just a touch. You broke me out of my concentration. I'll blame you for it. Let's see, because already I'm now looking bad.